In 2C, I need to clear the fractions, and so I look at all the denominators. And I have two fractions here. The denominator is x and a denominator of y. I look down here, and I've got two more fractions with a denominator of y and a denominator of x. So my common denominator of all those denominators is xy. So I'm going to multiply this whole fraction, this compound fraction, times 1, meaning xy divided by xy. When I do that, I'm going to distribute this xy to both of the fractions in the numerator. So y over x times xy, well, the x's would cancel, and you'd have y times y, which gives me y squared. I have a minus sign, so I put the subtraction symbol. Now I have the second fraction, x over y times xy. Well, the y's cancel, and I have x times x, so I get x squared. In the denominator, I have this fraction 1 over y times xy. The y's would cancel. You'd have 1 times x, which is x. Minus, so there's the minus sign. And then I have my last fraction, 1 over x times xy, and the x's would cancel, and I'd have 1 times y, which is y. Now, so this is what I have when I've eliminated all those compound fractions. I still have a fraction with y squared minus x squared in the numerator and x minus y in the denominator. But this is the difference of two squares, so I write the conjugate pair. It's the product of the conjugate pair. In the denominator, I had x minus y. If you factor out a negative, you can change the order of subtraction. So I factored out a negative 1, and instead of x minus y, I now have y minus x. Well, this factor y minus x in the numerator cancels with the factor y minus x in the denominator. And I'm left with y plus x in the numerator, a negative 1 in the denominator. So I'm just going to write a negative 1 out in front, or negative, and I have x plus y. Or you can distribute that negative, and you'd have negative x minus y. And in this case, I kind of like this better than having the negative and the grouping symbols.